Hello students, let's do mensuration exercise 23B. Before we start the exercise, let's revise a few formulae. So keep these in mind and learn it up so that you can apply it in your questions. First one is to find the perimeter of a rectangle. The formula is 2 into length plus breadth. So you add up the length and breadth and multiply it by 2. Perimeter for square. Remember, for square we speak about the sides and not length and breadth. So it will be 4 into side because there are 4 sides. Now the area. Area for rectangle will be length into breadth. Area for square is side into side. Now we've been applying these 4 formulae. Now there are 2 new ones. Area for parallelogram. When you're asked to find the area for parallelogram, this is the formula. Base into height. And if you're asked to find the area for rhombus, it will be half into product of diagonals when the diagonals are given. When diagonals are given, this is the formula, half into product of diagonals. Now let's begin the exercise. Question 6. Find the area of the square whose perimeter is 56 centimeters. So here we have a square. Now the perimeter is given to us. Remember, perimeter is what is on the border, boundary. That is the perimeter. Now that is given to us, but we are asked to find the area that is inside. Now to find the area of a square, we just went through the formulae. The area of a square is side into side, isn't it? So that is, if you have to find the area of a square, you say side into side. Now we don't have the value of side given to us, but we've been given perimeter. So with the help of the formula of the perimeter, let's see if we can find what side is. So let's begin. So this is given to us already, perimeter of the square, and we know that the formula to find perimeter of a square is 4 into side. So that is 4 into side is equal to 56 centimeters. So now from this we can find the side. So 4 into side is 56 centimeters. Now let's make this an equation. So now side will be equal to, we have 56 centimeters here, into 4 is what we have here. We're going to change that when it goes to the right hand side. 4, because it's multiplication, it will change to division. So this will become 56 divided by 4. 56 divided by 4 is 14. So 14 centimeters. So now we know the side is 14 centimeters. So in a square, remember, all sides are equal. So now we can find the area of a square by using the formula side into side. And that is 14 centimeters into 14 centimeters. So when you multiply 14 into 14, you get 196, and the unit will be centimeters square because we're finding the area. So we have found the area of the square. It is 196 centimeters square. Question 7. A square lawn is surrounded by a path 2.5 meters wide. If the area of the path is 165 meters square, find the area of the lawn. So this is a square lawn, yellow in color, and then we have the path around it, which is blue in color. So whenever you have questions like this, where you have to find the area of one square, either the inner or the outer, what we have to do is find the area of the inner square, find the area of the outer square, and then minus the 2. Okay, so here, this is the square. Now let's see what's given to us. It says the square lawn is surrounded by a path that is 2.5 meters wide. That means this portion, this much. This is the width of the square path and the path that is around the thing. So this is 2.5 meters wide. This is given to us. So everywhere, wherever you can see the blue line, it is 2.5 meters. Now we are told the area of the path. So we have the area of the blue portion, that is 165 meters square. We are asked to find the area of the lawn, that is the inner portion. So first we have to find the area of the square inside, and then the area of the square outside, and then when you minus the 2, you will find the answer. So what's given to us? Area of the path is given to us, then the width of the path is also given. So now we have to first find the area of the square lawn. So let's consider this side, the side of the lawn. Since we don't have that measurement to find the area, the formula side into side. Since we don't have the measurement, let's consider it to be x. So every side will be x of the square lawn. So let the side of the square lawn be x meters. So what is the formula to find the area of the square? Side into side. So that is the formula. So let's substitute side with x. We said x into x. X into x is x square. Okay, and the unit is meter square. So x into x is x square. We found the area of the square. Now we have to find the area of the outer square, isn't it? For that we need to have the measurement of the side. Now the outer side of, how do we get it? Now to get the outer side we need this whole measurement, isn't it? Starting from this end till the other end, that is the side. This is the side of the outer side. Now to get this outer side, what is the measurement? Now this much we know is x. Then this much we know is 2.5. And this is also 2.5. So that will be x plus 2.5 plus 2.5. So let's write that. So this will be x plus 2.5 meters plus 2.5 meters. So this will be x plus, how much is 2.5 plus 2.5? 5. So now we know that the outer side is x plus 5. Every side is x plus 5, x plus 5, x plus 5. Now we can find the area of the outer square by using the formula side into side. You know the side now, x plus 5. So side into side means x plus 5 into x plus 5, side into side, isn't it? So one side is x plus 5 and the other side is also x plus 5. So let's multiply these two. I hope all of you remember this kind of multiplication. Let me do it here. So x plus 5 into x plus 5. So in this case, we take the first x and multiply it with this whole thing. So that will be x into x plus 5. Then we take the next one, that is plus 5 into this whole thing, x plus 5. Now let's multiply each one. X into x is x square. Then multiply x into 5. That will be 5x. Then go to the other side. You have plus 5. Plus 5 into x will be plus 5x. Then you multiply plus 5 into plus 5. That will be plus 5 5s are 25. So this will be x square. Then we have 5x plus 5x, which is 10x plus 25. So this is what we have. So we found the area of the outer square, which is x square plus 10x plus 25. So now we have the area of the square lawn, which is x square, and we have the area of the outer square, which is this. Now, if we subtract these two, we will find the area of the square lawn. Okay, so we write area of the path. Now here, area of the path, that is this path, we can find it by subtracting area of the outer square and area of the square lawn. Now we actually need the area of the square lawn, isn't it? But we're going to use this to find the area of the square lawn. Area of the path is already given to us. Area of the path is 165 meters square. It's given to us in the question. So let's substitute. So this will be 165 meters square. This is equal to area of the outer square. How much is the area of the outer square? We just found out x square plus 10x plus 25. And we subtract the area of the square lawn, which is x square. Okay, so I hope you've understood this. So I've substituted the area of the path, which is already given to us. Area of the outer square we found out to be this much, and area of the square lawn we found out to be x square. Now let's subtract. Now here we have plus x squared, understood, isn't it? Now plus x square and minus x square, that is plus 1 minus 1 is equal to 0. So this will get cancelled. So what do we have here? So this is now an equation. 165 meters square is equal to 10x plus 25. So now we have to find the value of x, isn't it? Because we said that the area of the square lawn is x square. So we need to find the value of x. So let's find the value of x here. So we are going to leave this equation with 10x here. And on the other side, we have 165. And we are going to take this 25 to the other side. Here it is plus, it will become minus. Minus 25. So that is 10x is equal to 165 minus 25, which is 140. If 10x is 140, x will be equal to 140 divided by 10, because here it is 10 into x. When we transpose it to the other side, it becomes division. So now we know x is equal to, now 140 divided by 10 is 14. So we know that x is 14. Now we have to find the area of the square lawn, which is x square. So x square will be x into x. X square is x into x, which is 14 into 14, which is equal to 196. So we have found the area of the square lawn to be 196 meter square. So this is our final answer. Area of the square lawn is 196 meter square. Question 8. For each figure given below, so this is the first figure, find the area of the shaded region. All measurements are in centimeters. So measurements are given to us, it's in centimeters. So here this is the shaded region. So as you can see, you have an outer region, if you take the whole thing, and an inner region, unshaded one. When you subtract the two, you will find the area of the shaded portion. Okay, so we have to first find the area of the whole region. Then we must find the area of the inner unshaded portion and subtract the two. So let's begin by saying the outer length is given to us as 20 centimeters. Outer breadth is given. So we're talking about the outer part. That is the whole region. So now to find the area, the formula is length into breadth. So what do we have here? The outer area, that means the whole region. We're talking about this whole thing. Okay, the whole thing. The formula is length into breadth. We have length, we have breadth here. So let's apply. Length is 20 centimeters into breadth, and breadth is 16 centimeters. So length into breadth, that is 20 into 16. So multiply the numbers first without the 0. 16 twos are 32. Add the 0. And since it's area, the unit is centimeter square. So we found the outer area. Now let's find the inner area, that is the area of the unshaded portion. So that is the inner length is given to us, the inner breadth is given to us. So to find the inner area, that is the unshaded region, the formula again is length into breadth. And the length is 15 centimeters. Breadth is 10 centimeters. 15 into 10, 15 ones are 15, add a 0, centimeters square. So now can you see we have found the area of the outer region and the area of the inner region, the unshaded portion. Now all we have to do is subtract the two areas. We will find the area of the shaded portion. So the way to do it is the area of the shaded region is area of the whole region minus area of the unshaded region. So the area of the whole region is 320 centimeters square minus the area of unshaded region is 150 centimeter square. So when you subtract this, you get 170 and the unit is centimeters square. So we have found the area of the shaded region now, and that is 170 centimeter square. Now question 2, this is the shaded portion and we have to find the area of this shaded portion. Inside this there is a small portion which is unshaded. So just like the previous one, we have to find first the area of the whole region, then the area of the unshaded portion, and then subtract the two. So let's begin. Area, to find area, the outer length is given to us as 30 centimeters. Outer breadth is 20 centimeters. So to find the outer area, that is the area of the whole region, it is length into breadth, which is 30 centimeters into breadth, which is 20 centimeters. So 3 twos are 6, and then add the two zeros, 600. centimeters square. This is the area of the whole region. Now, the inner length is 12 centimeters. The inner breadth is also 12 centimeters. That means that is a square, isn't it? So the inner area, unshaded region, will be side into side. That is 12 centimeters into 12 centimeters. 12 into 12 is 144 centimeters square is the unit. So now that we have found the whole region's area and the unshaded region's area, we have to subtract the two. So let's do that. So the area of the shaded region will be area of the whole region minus area of the unshaded region. So area of the whole region is 600 centimeters square, and we have to minus the area of the unshaded region, which is 144 centimeters square. So when you subtract these two, you get 456, and the unit is centimeters square. So we have found the area of the shaded region, and that is 456 centimeters square. Question 3, here also we have a shaded portion and we have an unshaded portion. So first let's find out the area of the outer portion, then the area of the inner region, and subtract the two, just like the previous questions. So outer length is 40 centimeters and outer breadth is also 40 centimeters. So that is a square, that means. So the outer area, that is area of the whole region, will be side into side, which is 40 centimeters into 40 centimeters. Multiply 4 into 4, 4 fours are 16, and add the two zeros. 1600 centimeters square. This is the area of the whole region. Now let's find the area of the unshaded portion. So the inner length, that is 32 centimeters. Inner breadth is 15 centimeters. So the inner area, that is the unshaded region, is length into breadth, which is 32 centimeters into 15 centimeters. 32 into 15 is equal to 480. So this is 480 centimeters square. So the area of the whole region is 1600 centimeters square. Area of the unshaded region is 480 centimeters square. Now to find the area of the shaded portion, subtract the two. So area of the shaded region is area of the whole region minus area of the unshaded region. So whole region is 1600 centimeters square minus area of unshaded region is 480 centimeter square, which is equal to 1120 centimeters square. So we have found the area of the shaded region, and that is 1120 centimeter square. Question 4, here also we have the shaded portion and we have the unshaded portion. So first find the area of the whole region, then find the area of the unshaded portion, and then subtract the two. Let's begin. Outer length is 40 centimeters. Outer breadth is also 40 centimeters. So it's given to us. So that means this is a square. So the outer area, that is the area of the whole region, will be side into side. That is 40 centimeters into 40 centimeters. 4 fours are 16. Add the two zeros. Centimeters square. So this is 1600 centimeters square, which is the area of the whole region. Now we're going to find the area of the unshaded portion. So that is the inner length is 15 centimeters. Inner breadth is also 15 centimeters. That means the inner area, or the area of the unshaded region, will be side into side again. That is 15 centimeters into 15 centimeters. 15 into 15 is 225, and the unit is centimeter square. Now to find the area of only the shaded portion, we have to subtract these two areas. So area of the shaded region will be area of the whole region minus area of the unshaded region. Area of the whole region is 1600 centimeters square, and the area of the unshaded region is 225 centimeter square. Let's subtract these two, which is 1375, and the unit is centimeters square. So we have found the area of the shaded portion to be 1375 centimeter square. Okay, so here we've been given a figure, just a figure that has been shaded. Now we have to find the area of this shaded figure. So what we can do is we can split them up into different rectangles. We can take this as rectangle 1, rectangle 2 and rectangle 3, and then when we add up all three we will get the area. So let's take up only the first area, first rectangle. That is the one that we just saw now. This is the one. We're going to find the area of this rectangle and the formula is length into breadth. So we'll consider that as rectangle 1. Length into breadth, and the length is 20 centimeters and the breadth is 2 centimeters. So 20 into 2 is 40. So 40 centimeters square is the area of rectangle 1. Now let's take rectangle 2. So that green portion is rectangle 2. So let's find the area of rectangle 2, that is length into breadth again. Length is the longer portion. That is, we are talking about 8. Now 12 here will be all this included. 8 plus we have 2 here, isn't it? Plus 2 here will make it 12. But we are not looking at the whole thing. We are looking only at this green rectangle, and there the length is 8. So the length is 8 centimeters. So that is 8 centimeters into. Now how much is the breadth? Now this is the breadth. Remember, this is the breadth here, and the breadth is given to us here as 2. So here that is 2. Now how do we know that that is 2 there? Okay, now look at this whole length outside. That's 20, isn't it? And only this portion here is given as 18. That means this whole portion also should be 20. So 18 plus 2 will give us 20. So this is 2. So the breadth for this rectangle will be 2 centimeters. So 8 into 2 is 16. So that is 16 centimeter square. Now let's go to the third rectangle. The blue one is the third rectangle. Now here, let's write this. Area of rectangle 3 is length into breadth. Now how much is length? Now this portion alone is 12. So this whole portion will be how much? Remember we said this small portion here, that is, let me mark that here. This small portion here is 2 centimeters. So that means we need to add 12 plus 2. 12 plus 2 is 14. That means the length is 14. Length is 14 centimeters and breadth is 2. So breadth also we know is 2. This portion is the breadth. How do we know that this breadth is 2? Now look at this. This is 12. This whole thing is 12. That means 8 plus this portion, which is 2. 2 is already given to us. 8 plus 2 is 10. So what is remaining? It should be equal to 12. So 10 plus 2. So we know that this portion is 2. So the breadth is 2 centimeters. So 14 into 2 is 28 and the unit is centimeters square. So now that we have found the area of rectangle 1, rectangle 2 and rectangle 3, now we can find the area of the shaded figure. We just have to add up all three. So the area of the shaded portion will be area of rectangle 1 plus 2 plus 3. So let's add it up. 40 centimeters square plus 16 centimeters square plus 28 centimeters square. So add up all these. What do we get? We get 84 centimeter square. So the area of the shaded portion in this figure is 84 centimeter square. Question 9. One side of a parallelogram. Now what is a parallelogram? It's a figure like this. It's a four-sided figure with two pairs of parallel lines. Remember, parallel lines are two lines that don't meet. And look at the opposite sides with the two arrowheads. That means this is one pair of parallel lines and this one with one arrowhead. These two form another pair of parallel lines. So this figure is a parallelogram and it says one side of a parallelogram is 20 centimeters. So let this be 20 centimeters. One side is 20 centimeters and its distance from the opposite side is 16 centimeters. Distance means this space. This space from the opposite side is 16 centimeters. So this will be 16 centimeters. Now we are asked to find the area of this parallelogram. So now let's just name it A, B, C and D, and this portion as E, where this line touches this line here at the bottom, we'll name it E. Now here this is forming 90 degrees parallel lines here. Now this figure, this portion DE forms 90 degrees here. Okay, now we are asked to find the area of the parallelogram. Now there is a formula to find area of a parallelogram, that is base into height. Now which is the base? AB. AB is the base. Here, as you can see, this is the base AB and that is 20 centimeters, and the height is DE, which is 16 centimeters. So let's substitute. Area of the parallelogram is AB into DE. AB is 20 centimeters and DE is 16 centimeters. So let's multiply 20 into 16. 16 twos are 32, at the 0, and the unit is centimeters square. So what is the area of this parallelogram? 320 centimeter square. Question 10. The base of a parallelogram is thrice its height. If its area is 768 centimeters, find the base and the height of the parallelogram. So first let's write what's given to us. What is given? Area is given to us, and we are also told that the base of parallelogram is thrice its height. That means first we should know the height. So let the height of the parallelogram be x. So now we can say that the base of the parallelogram is 3x because it says thrice its height. That is 3x. So what all do we have now? We have the area of the parallelogram, we have the height and the base. So let's make use of this uh, area formula. That is, area is base into height. Let's substitute whatever we can. Area is already given to us as 768 centimeters square, and the base we said is 3x into height, which is x. So now this is an equation. 768 centimeters square is equal to 3x into x, which will be 3x square. Now we are going to find the value of x. So we'll put this equation symbol here. So 3x square is equal to 768. So let's find the value of only x square. X square will be equal to 768 divided by 3, because we are transposing this 3 to the other side. It's become division. Now divide 768 by 3. You get 256. So that means x square is 256. So how much is x? X will be the square root of 256. So we have to find the square root now of 256. Let's use the prime factor method. 256 divided by 2, 2 ones are 2, the next number is 5, 2 twos are 4, 1 is left, so 16, 2 eights are 16, continue, 2 sixes are 12, 2 fours are 8, 2 threes are 6, 2 twos are 4, 2 into 16 is 32, 2 eights are 16, 2 fours are 8, 2 twos are 4, and 2 ones are 2. So now let's count how many 2's there are. 1, 2, 3, 4, 5, 6, 7, 8. So let's write it down here. So that will be 1, 2, 3, 4, 5, 6, 7 and 8. Now pair it up because we're finding the square root. So put it all into a pair. There are 2 in each. Take out 1 from each. So this is 2. Then here into 2, into 2. 1 from each is what I've taken. So multiply all these. 2 twos are 4, 4 twos are 8, 8 twos are 16. So this is 16. That means we have found the value of x to be 16. Now that we have found x to be equal to 16, we can find the height and the base. We've been asked to find both, isn't it? So we can find the height and the base. So let's do that. So the height is x, isn't it? We said let the height be x. So height is x, which is equal to, which we just found out now to be 16. So that will be 16 centimeters. The height is going to be 16 centimeters. So we found the first one. Now we can find the base also. And base, remember here we said base is 3x because the question says the base of a parallelogram is thrice its height. Height is x, so the base will be 3 times x, 3x. 3x, which is 3 into, and how much is x? 16, and 16 threes are 48. So the base is 48 centimeters. So now we have found the height to be 16 centimeters and the base to be 48 centimeters. Question 11. Find the area of the rhombus if its diagonals are 30 centimeters and 24 centimeters. Okay, so here, what is a rhombus? It is also a quadrilateral, a four-sided figure with both pairs of opposite sides parallel. Can you see? Both pairs are parallel and all sides will be the same length. Okay, so these pairs are parallel to each other and all sides are of the same length. So this is a rhombus. It is actually an equilateral parallelogram. Now to find the area of this rhombus, first let's write down what's given. Now there are two diagonals, so we'll call it diagonal 1, 30 centimeters. So we can say diagonal 1 is 30 centimeters. So let's name this as diagonal 1, D1. Okay, and diagonal 2 is given as 24 centimeters. That is this one. Diagonal 2 is 24 centimeters. It's given to us. Now, when two diagonals are given, to find the area, the formula is 1 by 2 into product of the diagonals. That is, you multiply the two diagonals and divide it by 2 or multiply it by 1 by 2. So let's write that 1 by 2 into product of the diagonals. That is, the first diagonal is 30 centimeters. Second diagonal is 24 centimeters. So multiply these two. So this will be 1 by 2 into 30 into 24. That is 720 centimeter square. Now we can cancel 2 and 720. 2 ones are 2, 2 threes are 6, there's 1 left, that is 12, 2 sixes are 12 and the 0. So that is 360 centimeters square. 1 into 360. So the area of the rhombus is 360 centimeter square. This is our final answer. Question 12. If the area of a rhombus is 112 centimeters square and one of its diagonals is 14 centimeters, find its other diagonal. So here what is given to us? The area of a rhombus is already given to us and one of its diagonals is also given to us. Now we have to find the other diagonal. So let that be x centimeter. Let the second diagonal be x centimeter. Now we have area, we have one diagonal, we have to find the other diagonal. We can use the formula of area. And what is the formula? Area of a rhombus is half into product of diagonals or 1 by 2 into product of diagonals. Now let us substitute with whatever values we have. Area of the rhombus we already have, so that is 112 centimeters square. That's already given to us. Now 1 by 2 into product of the diagonals, that is diagonal 1, which is 14 centimeters, and diagonal 2, which is x centimeters. So now this is an equation. So 112 centimeters square is equal to 1 by 2 into 14 into x is 14x. So that is 14x centimeter square. So now 112 centimeters square, here on the other side 1 by 2 into 14x. So now it is 1 by 2, so we can cancel 2 and 14. So here it is 7. So what do we have here? 1 into 7 is 7. So that is 7x. 7x centimeters square. So now we're going to find only the value of 7x. 7x is equal to 112. Let's find the value of x. So this will be 112 divided by 7. Because we have transposed the 7 from here to the other side, it's become division. So now 112 divided by 7 is equal to 16. So x is equal to 16. And what did we say x is? The second diagonal. So we have found the other diagonal, and that is 16 centimeters. So the other diagonal of the rhombus is 16 centimeters. So this is our answer here. So children, we will stop with this for now. In our next video, we will continue with the remaining questions. Thank you, children.